Hi, my name is Carsten Jacobsen. I'm a senior developer advocate at Stellar Development Foundation. In this video, we'll take a closer look at the Guestbook demo Dapp, which you can also find in the documentation under the Build tab. First, we'll take a high-level look at what the Guestbook does and try out the live version of the Guestbook. Then we examine the high-level architecture of the Dapp. We go through the smart contracts that are used for reading and storing messages. The Guestbook uses TypeScript bindings to connect the front end and the smart contracts, so we take a quick look at the front end bindings. The Guestbook uses passkeys for user authentication, so we walk through the requirements for integrating passkeys. The Guestbook Dapp is a really good example of a complete Dapp built on Stellar. It's a simple Dapp, it's easy to understand what it does, and yet it's built using some really cool Stellar features. Let's try the Dapp so we have some context when we walk through the architecture and the code. This is how the Guestbook looked like if you follow the link in the previous slide. Without signing in, we can read the messages in the Guestbook. But we want to sign the Guestbook, so let's create a user account by signing up. Provide a name. And because we're using passkeys for creating a user account and signing the transactions, we get this pop-up requesting me to use my fingerprints on my laptop. Okay, when we see the cog up here, it means that our account was created. We can see the account wallet here. And we have an option to fund the account, and there are other features here we will not cover in this presentation, but you can go ahead and play around with that on your own. Okay, let's sign the Guestbook. When I click the sign button, I will get a pop-up asking for me to use my fingerprint scanner. So I did now. And then we are signing the transaction here. And the message has been stored. Okay, so if we go back to read, we'll see the new message here is the second one. The first one is always the same. It's added by the admin at the time of setup, but we'll cover that later. Let's go back to the presentation. The Guestbook Dapp stores messages on-chain by using smart contract functions. The front end is connected to the smart contract functions through TypeScript bindings, and the Guestbook uses passkeys for convenient user sign-up and login, so no external wallet is needed. Passkeys is a convenient walletless way for users to sign up and log in. Passkeys does require a couple of external services to operate. LaunchTube is similar to a paymaster service. The passkey key needs it, but we don't interact with it directly. The Mercury Zephyr is an indexer, and we use it for the passkey kit. Let's get into the smart contracts. The Guestbook smart contracts consist of 5 functions. We have a write message, edit message, read latest, and claim donations. As mentioned in the demo, we are not going to cover the features like donations and the wallet, but we will go into the details about storing and writing and reading messages. The write message function is used to add a new message to the Guestbook. First, the function checks if the title and the text parameters are not empty, and then if the user is authorized to write a message. An instance of message struct is created with the message data, including the author, the current ledger sequence number, and stored with the utility function saved message. The edit message function is used to edit a message. First, the function check if either title or text parameters are not empty, get the current message data, and then checks if the user is authorized to edit this message. The existing message data is updated with the parameter data. If either title or text is empty, the existing values are used. Finally, the message is stored. The read message function is used to get an existing message from storage. This function is simple since anyone can read messages in the guestbook without being authenticated first. The message is read with the utility function getMessage. The readLatest function is a convenient way to get the last message added to the guestbook. First, the function gets the message count to get the ID of the latest message. Messages are never deleted, so the message count will be equal to the ID of the last message. The latest message is read with the utility function getMessage that takes the message ID as an argument. Like the readMessage function, readLatest doesn't require the caller to be authenticated. Most of the donation functionality is handled by the front end. The smart contract function just claims the donation. First, the function creates the token client, check the contract's balance of that token, and if there's a positive balance, then we send the tokens to the admin address. This workshop doesn't go into details about the donation feature. See the documentation for more details. The Guestbook smart contract functions use a few utility functions that are used in the previous mentioned contract functions. We have check string not empty, we have a get message, and a save message. The check string not empty function is used to check if the string is empty or not. If the string is empty, an error is thrown. The get message function is used to read a message from storage, and it contains error handling. First, the function checks if the message with the ID provided as a parameter exists, and if it doesn't, an error is thrown. If the message do exist, the message is read from storage and returned to the calling function. And finally, we have the save message function, which is used to write a new message to storage. Please note that this function is only used to store a new message and not to update an existing message. First, the function initializes a value with the current message count and increments this value. Please note that the message counter is stored separately from the message storage. Next, the message is written to storage using the incremented message count as the key and the message from the function parameter as a value. Finally, the incremented message counter is stored and returned. Let's take a look at the front-end bindings. We need a way to invoke the smart contract functions from a web-based front-end, and this is where the TypeScript bindings come into play. The Stellar CLI can generate and produce a fully typed NPM package ready for integration into your front-end. This means that you can invoke smart contracts by adding the binding package and use its interface. Let's take a look at how to set up the bindings for the Guestbook front-end. Before we can create the front-end bindings, we need to have our smart contract built and deployed. In this case, we deploy it to testnet. We use a few information like the admin, the title, and the text when we deploy the message. And this is the first message you saw in the test book, the one provided by the admin. It is actually set up through the deployment process. Now we have built and deployed our smart contracts, we can start to generate the bindings. Run this Stellar CLI binding command using the contract address. Use the contract address returned by the deploy command. The binding package is now generated in the package/ye guestbook folder. Now install and build it. The last step is to import the binding package as a project dependency so we can use it in the front-end code. After building and installing the TypeScript contract bindings, we have a package in the front-end project's node module folder, and we can use it as any other NPM package. The example on the right here is a simplified version of a contract function call in the guestbook, but it serves well as an example of how the bindings can be implemented. First, the package is imported and the guestbook client is instantiated with the appropriate network settings, in this case, testnet. The read message contract function can now be invoked using the guestbook binding client. Let's take a closer look at how we can use passkeys to authenticate users. The passkey kit has a client and a server part. Passkeys relies on two services, LaunchTube and Mercury Zephyr. Let's look at the services first. LaunchTube is similar to a paymaster service if you're familiar with the account abstraction in EVM networks. LaunchTube is needed by the passkey kit package and is used for submitting passkey signed transactions to the network. Zephyr is a data indexer service, and it's used for reverse lookup of smart wallet contract addresses based on passkey IDs. So a user's smart wallet address easily can be retrieved at login. The passkey integration with the guestbook is split into two. There's a passkey client that is used by the Svelte frontend, and it deals with all the user interactions. There's a passkey server part that is used for secure communication with other services. To set up the passkey integration in the front end, we first need to create client instances for communicating with the network. We set instances up for accounts, for RPC, for SAC, and native, so we can use XLM tokens. The client has some helper functions that make integration easy. The first helper we look at is the send function, which is used to send transactions to the network through LaunchTube. We also have the helper functions getContractID and fundContract. GetContractID is a function that takes the passkey ID as a parameter and call the server endpoint that will retrieve the contract address from Mercury Zephyr. The fundContract is a function that is used to fund the user wallet, since FriendBot can't fund C addresses. The passkey server gives us an importable server instance that can be accessed and used in other server-side logic. This server instance will be used for sending transactions through LaunchTube and reverse lookup contract addresses from a known passkey ID through Mercury Zephyr. The passkey server creates the endpoints mentioned in the client helper functions. See the documentation and the code for deeper understanding of how the passkey server works. Also, Svelte gives us the added benefit of keeping the code in this directory safe, so sensitive credentials, tokens, etc. are not exposed. Finally, we take a look at the Dapp front end. High level, the front end consists of a Svelte framework. The smart contract functions are invoked through the generated front end bindings, and the passkey kit is imported and provides the passkey authentication functionality. Most of the front end is not different from any other Web 2 front end, so let's dive into some of the more Stellar specific integrations. This illustration shows how the front end renders a guestbook message in the browser. The Svelte application has three parts: the page markup rendered in the browser, a server populating the page, and a message component for formatting the message data. The Svelte server provides different ways to get the messages. The front-end bindings and the passkey kit instances are used to get messages from the network. Let's take a closer look at the get ledger entries usage to understand how messages are retrieved. We have two functions here. We have the get welcome message and get all messages. The welcome message is the first message stored by the admin when the contract was deployed from the ledger. The function uses RPC to get the messages with get ledger entries. The get all messages function will get all messages after the first message. It uses the function called get message count to get a total number of messages stored, and then iterates over the message count to populate an array of ledger keys representing the messages. Finally, the messages are retrieved from the ledger using get ledger entries. The messages are loaded when the page is loaded, and this is handled by the page server script. The message data will be available for use in the page vault. This page renders the read page where we see all the messages from in the front end, and it shows the welcome message and the complete list of messages. The code on the right is reduced. See the source code for the full code. The guestbook message component is used twice. First for showing the welcome message with the message ID equals 1, and second for showing the complete list of messages ID larger than 1. The message data is loaded by the page server TS when the page is loaded. This component renders the guestbook entry and takes messages and message IDs as props. The code is reduced down to just the script and the HTML to show the guestbook entry. The complete component includes both controls and functions to edit the message if the users are authorized to edit the message. Finally, we have the passkey integration. The passkey kit is handling the passkey prompt, so we don't need to do anything besides calling the passkey kit. The code here shows how the passkey kit is implemented for the login functions by calling connect wallet. The passkey prompt will automatically appear. Now you can go ahead and follow these links and try out the guestbook yourself. You can read about the sample Dapp here in our documentation, or you can go take a look at the source code.